video, we will learn about the addition rule for probability. So first off, to know the addition rule, we need to learn a few definitions to start. So a compound event is any event combining two or more simple events. And we'll usually call these events A and B. So disjoint means when events A and B are disjoint, or you could call them mutually exclusive, means they cannot occur at the same time. So here we have event A, and here we have event B, and we can see there's no overlap. They don't occur at the same time. So these could be things such as if you're rolling a dice and you can't roll a 1 and roll a 2 at the same time. That's impossible. So those would be disjoint. So the addition rule has two versions. There's one, the normal version, which is probability A or B equals the probability of A plus the probability of B minus the probability of A and B. Now, this is the rule when the events are not disjoint. So if the events are not disjoint, we will use this equation. Now, if they are disjoint, we're going to be able to use a different form of this equation. So say they are disjoint, then the rule becomes probability of A or B just equals probability of A plus the probability of B. So whenever we see our word or, we want to think addition. So or, we want to think addition. So say we have the probability of getting a 1 or the probability of getting a 2, so probability 1 or 2, these are disjoint. So that means to find the probability of 1 or 2, we can just do the probability of getting a 1 plus the probability of getting a 2. And we know from previously that the probability of getting a 1 is 1 over 6 because there were a total of 6 sided die in our sample space. And then we're just going to add the probability of getting a 2, which is same, 1 over 6. So the probability of getting a 1 or a 2 will be 2 over 6 or 1/3. So that's how we would solve one of these equations if we were given disjoint. Now, a lot of times we won't have disjoint, and that's when we're going to have to use the next addition rule. So if we have two events that are not disjoint, what we're going to have to do is we're going to have to take the probability of A. So we're going to say this one here is A. And we're going to take the probability of B, so that's this section here. Now we can see when we're doing this, we're counting this middle section twice. And the middle section here, we're going to call this A and B because this is where they both overlap for A and B. And sometimes in statistics we write and like an upside down U. So A and B is this middle section. Now because we counted this twice, what we're going to have to do is we're going to have to subtract one of them out. So if we subtract it out once, that means we'll have A, we'll have B, and we'll have the middle counted once. So that is why we subtract this part out. So when we don't have disjoint, we have to do probability of A plus probability of B and subtract out that part that they share, because otherwise we would be counting that part twice. When they were separate, we didn't have any middle section, so that's why we didn't have to worry about subtracting that part out, because we were only counting A and B. We weren't counting the overlap twice. So now we're going to do a couple examples with the standard deck of cards. So first we want to find the probability of selecting a 4 or a 5. Now you can't select a 4 and a 5 at the same time, so these ones are disjoint. So because they're disjoint, we can use probability of A plus the probability of B because we have our OR. So probability of A plus the probability of B. So the probability of getting a 4, you can see here there are 4 4s. And because we have 4 4s and our total is 52, the probability of A will be 4 over 52. And this will be the same with 5. So we have probability of 5, we have 4 of those. So we're going to also say plus 4 over 52. So our probability of 4 plus the probability of 5 is going to end up being 8 over 52. And if you want to change that to a decimal, you can, to get about 0.15. So that is the probability of getting a 4 or a 5. Now next we want to find the probability of selecting a 7 or a heart. So again we see the OR, so we want to use our addition rule. And this time you can get a 7 or a heart and a heart at the same time because we have this 7 of hearts right here. So because we have the 7 of hearts, these are not disjoint. So we're going to say it's not disjoint. That means we have to use the other rule, the full version of the rule. So what we need to do is the probability of A plus the probability of B. And we're going to have to subtract out that A and B. Minus A and B. A and B. So in this case, we want to find the probability of a 7 plus the probability of getting hearts. Let's make a heart. And we want to do minus the probability that it's a 7 and a heart. So 7 and a heart. Alright. So first let's find the probability of a 7. So we have 4 7s here. So again, the probability of 7 will be 4 out of 52. Then we have the probability of getting a heart. So looking at our sample space here, we can see that all of these are hearts. So if you count these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There are 13 out of 52. Or if you know your cards, you can use 1/4. That's how many suits there are. So 1 out of the 4 suits are hearts. But we'll do 13 out of 52 to make it easier. And now we want to subtract out the 7 and the heart. So if you can see, we circled the 7 of hearts twice. So that's why we need to take it out once. So there's one card that's a 7 and a heart out of the 52. So we're going to subtract out that. So 13 plus 4 will give us 17. And we're going to subtract the 1. So 17 minus 1 will give us 16 out of 52. And 16 out of 52 will be about 0.31. So the probability of getting a 7, or heart is 0.31. So when we're doing our addition rule, remember we're looking for the word or. Then we need to figure out if it's disjoint or not disjoint. If it's disjoint, we can just add our two probabilities together. If it is not disjoint, then we have to take into account the double counting of the and subtract that out. So that is how we solve problems of probability using the addition rule.